All right, the main part of this chapter is about the hydrocarbons. Okay, hydrocarbons, guess which two elements they contain? They contain carbon and hydrogen. And we have three major types of them. We have alkanes, alkenes, and alkynes. And you notice that the A, the E, and the Y are underlined. Okay, alkanes are saturated, which means that they are filled. They are absolutely filled with all of the hydrogens. They all have single bonds between all of the carbons. And alkenes are going to have a double bond. They're considered to be unsaturated because they removed two of the hydrogen in order to make room for the double bond between the carbons. Okay, and alkynes are going to have also an unsaturated hydrocarbon and they contain a triple bond. So they actually removed four of them, okay, in order to make room for the triple bond there. Okay, so what we need to start off with is our alkanes. Okay, an alkane has the A, so that comes first in the alphabet, and that's going to be the single. All right, so we are going to have the methane, ethane, propane, bute, pent, hex, hept, oct, none, decane. Okay, and meth, eth, prop, and bute are kind of very unique to organic chemistry, standing for 1, 2, 3, and 4 carbons. All right, do you remember how many bonds carbon makes? Carbon makes 4. So we're basically going to fill in our number of carbons, link them, and then fill the rest in with hydrogens. All right, so methane is CH4. So that means you have a carbon with 4 hydrogens around it. And it's going to look like that. Okay, ethane, which has 2 carbons, would then fill in 1, 2, 3, 4, 5, 6 hydrogens around it. And you would get the formula C2H6. What about propane? We have 3 carbons. 1, 2, 3 carbons in the chain. And then you kind of do in a T shape. 1, 2, 3, 1, 2, 1, 2, 3. That is 1, 2, 3, 4, 5, 6, 7, 8, or C3H8. Okay? How many would butane have? Butane would have C4H, you got it, 10. 1, 2, 3, 4. All right? And then you would put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, sometimes we kind of just leave this caterpillar looking form and it's assumed that you know how many hydrogens are going to fit in there. What about in pentane? C5H12. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what is our general formula here? Okay, when we have a certain number of carbons, how does the number of hydrogens respond to that? Well, each carbon can hold 2, and then there's 1 more on each end. So the formula is 2n plus 2. So for hexane, we would have C6H14, heptane C7H16, octane C8H18, nonane C9H20, and decane C10H22. All right, so another cool thing that I want to show you is a way that an organic chemist would write down any of these alkanes, because your hand kind of cramps when you write all these hydrogens, and even all of these things are, all these little caterpillar looking ones kind of get a little annoying after a while. So an organic chemist would take 1, 2, 3, 4, 5 carbons and draw it this way. That's it. This is pentane. And this is pentane. Yes, it looks like a letter M. But what you need to realize is that each one of these points is a carbon. And as long as you can remember that carbon can make 4 bonds, you don't need to do anything else. Okay, this is carbon 1, carbon 2, 3, 4, 5. This carbon would have 3 hydrogens on the end of it. This one would have 2, 2, 2, and 3. So what would butane look like? Butane up here would be like this. 1, 2, 3, 4. Propane would look like this. Ethane would look like this. And methane would look like that. All right, so you can remember meth, eth, prop, but as me, PB. I've used this for forever. I happen to really like peanut butter, so me want more peanut butter. All right, if you are allergic to peanut butter, I'm sorry, you can say me no likey peanut butter, and it somehow, works out for you as well. But that gets the prop and the but because they are not alphabetical at all. Okay, so our alkanes, our general formula is that CnH2n plus 2, and our branch method would be for your pentane, would have 1, 2, 3, 4, 5, and either have your hydrogens drawn out like so. This is a correct and acceptable form. Or you can just have your 5 carbons like so, just with your hydrogens indicated and assumed. Or you can do the organic chemist version and draw that. So you can either do 1, 2, or 3. Okay, you cannot have anything in between. Next, just to show you, there's lots of different ways to write all of these different formulas. Okay, you have your pentane, C5H12. You have a structural formula here where they kind of repeat these CH2s, so sometimes they're written like so. There's lots of different ways to show all these structures. And once you realize that this carbon has our tetrahedral orientation, and it's not actually a straight line, but you get this bumping motion to it. That's where we got this idea from. A chemist quickly writing this down to show that you have the carbon atoms in each one of these locations. Right, so that's how it kind of all came about. There's a lot of model kits that are used for these and those manipulatives to kind of help you visualize everything that you see. All right, our second type of hydrocarbon is our alkene. E comes next in the alphabet, and that means that you are going to have a double bond. We are going to start with the 2-carbon double bond because there is no methene, because carbon can make 4 bonds and it cannot double bond to a hydrogen because hydrogen can make 1 bond. So there is no methene. It is imposible. That's impossible for you non-Spanish speakers. All right, so you have ethene, propene, bute, pent, hex, hept, oct, none, and decene. All right, so we have C2H4. That would look like this. 2 carbons double bonded to one another, and then you would put in your 4 other hydrogens around it. Propene would look like this. Oops. And you would put in your 1, 2, 3, 4 on this one, 1 carbon here, and then 3 on that last one. Butene would be 1, 2, 3, 4, and you could have this in here, or you could have this. Are there the same number of hydrogens on each one? Let's count. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes. There are the same numbers on them. So what's the difference between these? If you number your carbons, carbon 1, 2, 3, 4, or carbons 1, 2, 3, 4, the double bond is going between carbon 1 and 2 here, and here the double bond is going between 2 and 3. So these are isomers of one another. Okay, you would name this one 1-butene or normal butene, and this one you would name 2-butene. Okay, there is no 3-butene because if you did 3-butene, carbon, 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 double bond, carbon, why can't you just number them 1, 2, 3, 4 instead? Okay, so that is where we get some trickery and some mind melting in our organic chemistry. Okay, so let's finish our patterns and then let's show you a couple more things. All right, so pentene would be C5. How many hydrogens if we put in a double bond? That's right, 10. And then hexene would be C6H12, C7H14, C8H16, C9H18, and C10H20 for decene. So our general formula would be CnH2n. Very good. We removed 2 of those hydrogens in order to get that in the correct spot. All right, so what we see here, all right, if we number our pentene, all right, this would be 1-pentene. And if we put our double bond, oops, wrong color here. If we put our double bond between the second and the third, oops, hold on one second. We would name this lower molecule 2-pentene. So I ask you, is there a 3-pentene? Is that possible? Or is it 2-pentene backwards? Let's take a look. 1, 2, 3, 4, 5. So between carbons 1, 2, 3, 4, and 5. Or if we number it the other way, 1, 2, 3, 4, 5. Ah, we number it the other way. There is only a 2-pentene. There is no such thing as 3-pentene. Interesting. Oh, I love you, organic chemistry. You definitely help change my mind about things. All right, so the general formula for our alkenes, which have a double bond, is going to be CnH2n. You name the position of the double bond, and the lowest numbered carbon gets the bond. So don't forget that we can number things from left to right or from right, whoops, I guess I did that backwards, right to left. So be very careful with that. All right, our branched method would look like this for 1-pentene or normal pentene. And you can draw in your hydrogens, where the organic chemistry method would look like this, and you would put your double bond like so. It's usually written on the bottom. All right, our next video is all about alkynes.